Okay. Hey, everyone. It's Brian. It's Friday. And you might have came on the stream and WTF? What's going on there? And so I only have one answer for you. As soon as I kill the audio. There we go. I got approached by somebody who I used to do up in Seattle. I used to do some prep courses for training. And I realized, at the time that we did this, I was, we were planning on setting up the LLC and the 501c3, which we had done all of that. And unfortunately, all that went away. Oh, all right. Congratulations, Jake. Jake may not be watching us. I don't know. But yeah, just saw your Slack message. Good on you, man. Hope you, get what you need there. Anyway, so I digress. And so reached out to me again after it was like 2018 and had said, hey, let me double check and make sure my audio is working. Okay, good. Hey, we'd like to do these again. It was pre-pandemic, would love to have you and, come along and do this again for us. And I was like, well, I've moved to San Diego. So the last ones were in person in downtown Seattle in a big high rise. And I was, it was a whole Saturday, but still it was like, I'd have to give up my Saturday, which I'm okay with doing. But I was like, unless it's virtual or there's some kind of virtual component, pretty much the commute's going to kill me. And the person said, hey, I'll get back to you and figure that out. So the education portion, or the lion, which you see on the logo, is something that I'm going to need to stand up eventually, because in addition to just doing streams and stuff, which is taking in whatever amounts of money it is, I'm keeping that in a separate bank account altogether from my personal assets. I realized if I'm going to be doing any kind of training, or if I'm going to make training for security or for any kind of education going in the future, I'm going to have to transcend the BreakSec podcast again. So BreakSec Education was born. And so I'm building out a logo and a presence, and nothing's going to change with the Twitch stream and the podcast and all that stuff. But I am going to be talking to some local B-Sides folks down here about setting up an LLC. And I hear there's a way to work the system. So if you do trainings, or if you trainings and give trainings, you can, use your company to pay for them. Why do I keep doing that? Legitimately paying for them, and you can take it as a business expense instead of paying out of pocket from your own company. So no huge change is going to occur. We're still going to do Twitch streams, and I'm going to do some Rust today. So thank you to my viewer who is here. I hope you're not a chat bot. But, it is what it is. So just to catch you up, if you didn't catch this last week, there was a blog post called The Minimal Rust Kernel. And again, I've been doing Rust for several shows right now. There we go. Turn that off. Actually, I'm going to need to... 1 second. Let me make sure everything's working. Everything is working, except for the spacing on the VS Code. There you go. Wow. Cross fingers. Damn you. Okay, so yeah, this is why I should use studio mode. I'm trying to click on my camera so I can move my camera output down. There we go. So it's out of the way of the code. So I saw this post in how to write an OS in Rust. So last week we went through and created for all intents, a bootload, a very minimal kernel, one that doesn't have, as you can see, a lot of things in Rust you have like a function main, which this doesn't have. You have like most scripting programs, your Node.js's, your NPMs, your Pythons and all that. There's a grip of dependencies, import this, import that, import world. Doesn't have any of those. Doesn't have any input. No standard. And so ideally what we've done, and the part that I highlighted here, which I should probably make a little bigger, is the underscore start. We're basically injecting ourselves into our stack, into the memory, and we're moving along. So the idea is, as we move down through this, let me see, where is it? Minimal kernel, Rust nightly. So you can see what we've done here. We've created, our GNU target to build our bootloader against a specific target type. I think it was this one here. Let me go config, yes. Here it is right here. So x86-64, so it's a x86 kernel, 64-bit. The platform, so where is it? Yeah, target parameter is unknown Linux, so it uses a Linux, and GNU is the type. So no clear vendor, right? So if it was like a Lenovo, in some case, why would Lenovo have that? But it's a Linux operating system with a GNU application binary input, ABI. ABI Linux. Application binary interface. Sorry, not input. So that's where we are right now. We compiled it. So I've scrolled through. We did a bunch of this stuff. The write-up is pretty good. I haven't had any issues so far, knock wood. And so what we're going to do is we're going to continue on through this, and we're building the kernel. So this is where we need to go. So yeah, compiling our new target, we'll use Linux conventions. This means we'll need an entry point into memory called underscore start, as described in the previous post. And so it's completely commented up here. Don't link the standard Rust library. So, the standard Rust library has certain utilities for handling errors, like panic errors. So if and it's the Rust standard library in this case is it's like a phantom library. It's just assumed that it's always called unless you explicitly do not call it. So in this case, no STD, which everybody, nope. And then, disable all Rust level entry points. So Rust level entry points would be the FN main, or func main in this case. So it says now we need, the entry point is start regardless of your host OS, and then we're going to build the kernel. So, we went through this iteration last week where we went through everything to build it correctly. And let me see if the terminal probably is, Rust. Ooh, yeah, we'll go to Rust. Yeah, so we're in Rust. TOML, Rust OS, blog OS, and then, so CD. Rust OS, blog OS. There we go. Yeah, there we go. All right. So if anybody has any questions, please let me know. I'll do my best to answer them as we go along. But we're going to continue on down through this. And so I think the next bit was I needed to install QEMU. We're going to print a screen. So the VGA buffer, right? Here's the text buffer. So this is the memory area mapped to the VGA hardware. So ideally, we want the contents to show up on the screen. So the VGA buffer is one of those, I don't want to call it a device driver, but it's a specific buffer of memory that contains 25 lines with 80 character cells. 25 by 80 output is ASCII characters. So you see the ASCII characters here. If you've ever played a game on a monochrome monitor back in the day, you might have used Sorry, I worked out today, so all that junk in my lungs is gone. So yeah, it'll use, if you've ever played NetHack or anything like that, you may recognize some of these characters from that game, from way back in the day or today. So we're going to set up, so we actually have to create an unsafe memory block around all the memory writes. So we have a specific area. It's an unsafe memory area because we're, let's see where, the reason is Rust can't prove the raw pointers we create are valid. So it doesn't trust us. So we have to create an unsafe method by which we inject Hello World into the system. And we went through and looked at the 5 things that are considered unsafe in Rust, which is dereferencing a raw pointer, calling an unsafe function or method, access or modify a mutable static variable, implementing an unsafe trait, or accessing fields of unions, I think is what it is. Let me scroll down. I think it said, and for some reason they called out the let's see where, wow, okay, there it is, union. Accessing fields of a union, and the union or unions multiple. So, all right. Hope everyone's had a good week. Mine's been fast because it was a short work week, but not a bad week so far. And we're gonna play with Rust. So at the end of this stream, it may be I'm pulling out my hair again and trying to figure out what to do. So hopefully it's not that case. I'd like to stay positive on this and learn a little bit. So all right, and we're gonna scroll down. So running our kernel. So we have to. Okay, so now we're caught up, and so the first thing we're gonna do is put on some music. Hey, Digital Warhead, how you doing? Since everything seems to be working on my preview, I'm going to turn that off. I was remarking on our Discord. Howdy doody. Hey, Digital Warhead, what do you think about the new icon or the new logo? You probably got here late, so you didn't hear me explain that. But if you go to, we have a new YouTube link, youtube.com/@breakseced. This should work. I changed it last night, so it's been the breaksec for several years. So I got a pretty blue lion. So for those of you who don't know, that's a combination of the doll stuff that I was working with. One of the streams we did, I was like playing around with generating icons and stuff. Same logo on Twitch. Oh, dang. Good catch, Digital Warhead. I will fix that at the end of the stream. I'm not sure why the card for the stream is still popping up with the old icon. It's a work in progress. We're working on it. But this is a combination of the lion is from DALL-E, and the icon and text and all that is from Canva, of all things. So cost me nothing to make, unlike the Breaking Down Security podcast icon from 2018 to now, or the one you see right there. Cost $500 and found out it was pretty much clip art with a fancy banner underneath. So that was our fault for not realizing that. But we found out, I think about 10 minutes after we showed it off to people in the Slack channel. Oh, hey, there's a high school with the exact same logo, and I was like. So, I got over that, but, I guess I didn't, because now it's like 5 years later, and I'm like, we need something a little different. So, Canva's actually quite good. Who owns the rights to it? Technically, I think I'm good. I think it's probably as long as I give credit. The good thing is, I don't think you can get that exact lion, because I went through, I don't know, ungodly numbers of iterations, and I wanted one that was kind of like a robot cyborg lion, and I was like, everyone does that shit. So I was like, nah, we'll just do this. So anyway, it took me a couple hours in Canva and DALL-E to make that, and, that's not bad, might be hard to put on a T-shirt or something, but we'll see what happens. It may only last a couple of weeks, and then I'll be back to the old logo. We'll see. So, all right. So we are caught up. It is pretty easy to use. They give you so many tokens a day, and I find that I went through several hundred iterations to the point where I didn't have any tokens left. All that did was delay the render time like 5 seconds or something. So I was like, whatever. So I did 200-300 iterations. So anywho, we're going to go ahead and run our kernel. Let me make sure I'm not like blasting into the red here. Okay, good. Just barely in the red. All right. So we're going to run our kernel. We're going to create a boot image. And it says to turn our compiled kernel into a bootable disk image. So like, an ISO or something from Ubuntu or Red Hat or Fedora or whatever. We need to link it with a bootloader. And a bootloader is, bootloaders like Grub or the Windows, Grub. What did I say? Man, I can't type for shit today. Grub bootloader. So you've got Grub. It's a multi-boot bootloader. You've seen it if you've ever booted up a Linux box. It's got your, ASCII box with, headers. You've got memsafe, you've got VGA safe, and then, if you dual boot it, like what I do with my laptop, it comes up with a, it tells me, hey, on Windows as dev SDA, or, you can just boot up to Ubuntu 22, and you can hit the down arrow and select whichever one it is. And it's I'd say it just works. For some reason, Linux's bootloader always kind of overrides the Windows bootloader, but I understand you can use the Windows bootloader to boot Linux. It's just a little on the janky side. So let's see here. There we go. So yeah, it's this is it. It's been around. Grub, and then Grub 2 is coming. Has been out for a while. So it's nothing new in any way, shape, or form, but we can use it. So we're gonna mount it to a bootloader. So we're gonna create a boot image, turn our compiled kernel into a bootable image. We need a bootloader, as we learned about in the section about booting. Bootloader is responsible for initializing CPU and loading the kernel. So the bootloader says, "Hey, here comes some instructions." And, then we use our kernel, or very rudimentary kernel, with the start to go, okay, we're going to inject ourselves into this part of the memory, and then we're going to have at it. Here's the instructions. Boom, make it happen. In this case, it'll be VGA offset, something. We're going to do the first thing we're going to do is we're going to give it some unsafe instructions. We're going to give it some memory unsafe functions to run because, we have to, because we want hello world. And then, ideally at that point, it's going to continue loading things. In this case, like the Linux kernel, it'll be 6 million? 30? No. Linux has, I don't know how many lines of code it has. I just saw something, Linux 6.6 lines of code. I thought I saw that like 33 million recently because of, that's in 2018. So yeah, here we go. Focusing on useful bits, 6.4 came out, 22 languages. I know I just saw a news article today, 27.8 million lines of code. That was as of 2020. So yeah, the 36 million sounds somewhat legit. So, tools past month. There we go. Yeah. 4 days ago. Oh yeah, here it is in FOSS. Yeah. Oh no, god damn it. It was Phoronix, I think, that saw that, but it was really heavy because they'd added a bunch of new support for like NVIDIA stuff and a couple of other items. So it's massive. Anyway, I've got 5, 6, I've got 29 lines of code in my kernel. It has 22 million lines of code in its. as to just to give you an example of that. So instead of writing our own bootloader, which is a project on its own, we'll use the bootloader crate. So we're going to, instead of a package, we're going to add a crate in this case. So in our cargo.toml, which is right here, we've already added our 0923 bootloader. And it says adding the bootloader's dependency is not enough. We need to create a bootable disk. And so we created a tool named boot image that first compiles the kernel and bootloader, then links them together to create a bootable disk image. To install the tool, go into your home directory and execute the following command in your terminal. So we're going to open an integrated terminal. And we're going to kill that terminal. We're going to use this one because it's in the right place. So, and then I will close this. Make sure it's big enough. I'm assuming the font size is big enough. If anybody has any issues seeing that white on black, let me know. Otherwise, I can shift it back to a black on white. So, all right. So cargo, install. Boot image. So crates.io index. We're going to be running some updates. Okay, so the boot image is updated. Please use force to override. All right. And then for running image and building the bootloader, you will need to have the LLM tools preview rust up component installed. So some of this sounds familiar. Yeah, like I've already run some of these items. Okay, so those are up to date. Cargo boot image. So we're building a kernel. And again, so the warnings, which I didn't learn the first time or the second time or the third time, I cannot put that stuff inside of Google Drive because the Google Drive it's not an actual hard drive. It's more like an asynchronous or synchronous transfer kind of. It's either one or the other. So it's not a real file system on the system. So I have to create things as they are. And doing things like garbage collection or hard linking files doesn't appear to work inside of Google's My Drive. So, but it did create the boot image for Blog OS. So as you can see, G, My Drive, GitHub projects, Rust. I put a space in GitHub projects. I hate myself. Rust, Rust OS, Target x64, Blog OS, debug, boot image.bin. So there's a bin file. We see the tool compiles our kernel using cargo build, which did it quite effectively. Are you dropping any frames on your end? Reduced my res to 480p and I'm still buffering. Might be my connection though. I am sitting with 170 skipped frames due to rendering lag out of almost 100,000 and 174 out of 92,000 with encoding lag. But I'm sitting at 60 frames a second, 2.1 milliseconds of render frame time. So I don't know. I'm hoping it's your connection, Digital Warhead. And I mean that in a nice way. I did have some issues with my one-on-one with my boss earlier today, but he was also having issues with his internet. So I was like, well, maybe it's his issue, not mine, or maybe there was an issue with the internets. You make me want to go and like bounce my router and my switch and all my other stuff. We'll continue on. If it gets any worse, Digital, let me know, and I will bounce something. So bounce down the stairs. I don't know. So, but thank you for the heads up. I appreciate that. After executing the command, you'll see this in your debug directory. You can boot it in a virtual machine or copy it to a USB drive to boot it onto real hardware. Note, this is not a CD image, which has a different format, so burning it to a CD doesn't work. So yeah, it's not in CD 9660 format, which is a specific format for, file systems. Yeah, so ISO 9660 file system for optical disc media. I just assumed way back in the day it was just another format, and but yeah, for a while there, when you could burn ISOs, it was like they gave you, you could burn it as a 9660 if you're going to burn it to optical, or you could just copy it to a thumb drive. And if you did make ISO-FS or anything like that in Linux, you had to, and you were going to burn it to a CD-ROM, then it would tell you needed certain switches set up for that. The Joliet specification, yes, Nero burning ROM was the thing back in the day. Make ISO-FS, image burn is another good one. Yeah. Nero burning ROM was awesome. One of the first applications I might have gotten generated keys for. Hey, Freedom DAO. Yeah, I mean, I'm doing Rust right now. Yeah, I like image burn still from time to time. I still have a couple of CDs around here. I think I have a burnable DVD RE or BDRE that I can use. It has 50 gigs worth of space on it. So, in the event I ever find myself needing a disk to write things to. But yeah, make ISO-FS, grow ISO-FS for DVD burning. So yeah, you'd use, when I was doing OpenBSD, a whole OS. Well, yeah, in this case, the minimal Rust kernel. Yeah, you can. I've created the bin file, and now I have to boot it in QEMU, which I do not have installed yet. This person wrote this, I think, on. Yeah, so it says, now we can boot the disk image in a virtual machine. Crap. That's not helpful, Digital Warhead. It's supposed to be your problem, not mine. No, I'm just kidding. All right, well, if it gets any worse, please let me know. I posted it up in chat, Freedom DAO, but I'll post it again just to make sure everybody has it. Paste. There we go. Oh, yeah, I probably should post it to the... let me see here. Yeah, I'll post it up to the, there we go. All right, where's the chat at? There it is. All right, I'll make sure I post it in chat. If you see a bot, don't tell me. Okay. Cheese. All right, so... Let me pull up my browser, or let me pull up a terminal window. None of you can see this over here, so talk amongst yourselves. So what I'm going to do is I'm going to attempt to install QEMU inside of my Linux WSL distribution. This may not work. We'll see. So sudo. Yeah, ask Freedom DAO. Good question. Install. No, it looks great. Okay, good. Yeah, I've only dropped, in the last 10,000 frames, I've only dropped another 5 frames, roughly. So, yeah, I don't know what's up, but, and install QEMU. My password. All right, so I'm in package QEMU is not available, referred to by another package, may mean the package is missing or has been obsoleted or is available only from another source. Every time I've been on streams, it's been insanely good, like everything, text size, etc. Don't bullshit me, Freedom DAO. I'm not lead hacksaw. I'm freaking TPM. I appreciate the flattery, though, but checks in the mail, Freedom DAO. Let me, let me see. Should I? You know what? Let's go and I think I could probably install VirtualBox. This is gonna hurt because if this doesn't work, then I don't have a good way of testing this to make sure it works. Some people. Oh, you know what? Wait. Do I have VMware installed? I do not have VMware installed. Okay. Well, I do have I have the Hyper-V manager, but I don't. Yeah. Fuck it. Let's just install. Everyone goes back to VirtualBox eventually. Windows hosts. All right, so we're going to install some VirtualBox. Get our UAC on here. Well, you know, Freedom DAO, I've tried Hyper-V, I've tried VMware, I've tried QEMU, I've tried Box, I've tried a ton of different things. And for whatever reason, everyone goes back to VirtualBox because, one, it's free, and pretty much everyone knows it. It's got its little peccadillos, but it's, as much as I hate the fact that it's owned by Oracle, it is what it is. All right, so we're going to install VirtualBox. Ooh, God, that's not good. Okay, so I'm getting the warning message about, you know, this will disconnect you and temporarily disconnect you from the network. I didn't think about that. Yeah, that'd be bad. Let's, you know what? I'm just gonna set that aside for a second. All right. So, one thing you should not do when you're trying to, you know, I'm not gonna. I don't. Let me double check and make sure I don't have it automatically installed already. Okay. What was it? System. Ah, okay. Oh, that would be my wife landing in St. Louis. Okay, so I didn't pick the right package for QEMU, so I'm going to. Excellent. Good flight. All right, so it's installing QEMU-system. So that's what I was looking for. I should have done QEMU-system instead of just straight QEMU. Hopefully I can run this from the command line. Let me enable preview. All right, and no. Okay, so I need to show studio mode. All right, and then add window capture, terminal, and then Windows 10 and up. Okay, apologies for the, oh, okay, so that's cool. All right. Shrink that down a little bit so everybody can see it, and then I'll just turn it off when I'm done. All right. Doink. Look at me, I made transitions. All right, so we've got the system up. I ran that command right there, apt install QEMU system, because originally I installed this and I got an error message. So I need a QEMU system. So we're gonna go, nice. All right, so QEMU. All right, so you see all the different options they have here based on the different architectures. You have Alpha, Arch, ARM, HP, i386, some of the MIPS stuff. You got some PowerPC items. I mean, really going way back in the day, RISC 32 and 64-bit. You know, you've got all kinds of stuff. So we want this one here, the x86-64. So we're going to go with QEMU system. x8664, and then we're going to be, oh gods, okay, I've got to I have to copy that. You know what, I almost want to go, do I just need the bin file? I just need the bin file, right? Okay, yeah, so ls. All right, so cd target, and then X, and then debug, and then, all right, so ls. All right, so there's blog OS. Yeah, so there's the boot image. It's 68,000K. So there's that. Oh, okay, you can see that under there. Let me scoot that up and scoot myself up. So yeah, there you see the bin file. All right. All right, so we're gonna cp boot c : documents and settings. Oh, users. Oh, this is painful. Okay. All right. Yep. All right. So let's see. My drive, GitHub projects. What I want to do is I want to put this someplace where I'm not going to have to type a bunch of shite. Rust OS, Blog OS, Target, Debug, Target, Nergit. Yeah, there. Oh, Blog OS. There it is. Debug, and then the bin file. All right, copy. And then we will put it on the desktop because that's how real PMs do it. All right, so QEMU, all right, slash our dash drive format, our drive format raw file equals C colon. Probably better off just leaving it right where I had it. Nope, you know what I'm gonna do? All right, cdg colon. Oh, wait. There it is, okay. mntg. All right, cd my drive. cd my drive. GitHub. Rust. OS, blog, OS, Target, x86, debug. See, if I was an editing video, I would have edited all this crap out. Yeah, I'm still working on how to learn how to video edit and everything. So, all right, so you see what you see here. So there's the blog OS bin. All right, so system x86 64. Okay, so just wanted to make sure that worked. All right. Drive, format, raw, file. I'm just going to go equal./boot. All right. That's it. Okay. It says GTK initialization failed. I'm thinking it's going to fail when I hit enter, but we'll see. We'll see. Yep. Okay. Man, that sucks. All right. Well, I'm I'm going to. So here's what I'm going to do. I will create something earlier or later on today. Everything matches with what is in the script. Everything matches with what's in cargo.toml. I'll make a little vignette later showing after I've installed VirtualBox or something and run it and show the hello world bit. We're going to continue on through. If you have any questions or, I can always take a screenshot of my desktop with hello world running on it if people, get that. They say it's also possible to write it to a USB stick and boot it on a real machine, but be careful when to choose the correct file name because everything is written on that file on that device is overwritten. Okay, so yeah, you're going to use a dd command with the target. You're going to go to the bin file. You're going to output to SD. Depending on the thumb drive, it's going to be like SDB because your hard drive will most likely be SDA, and then sync. And that just says, close all any file handlers or anything that's going on between your system and the thumb drive, and make sure everything's copacetic before you decide to shut it off. And I think I forget the sync part when I'm burning ISO sometimes because I'll get a bad DD build or a burn or something. So, but yeah, ideally what's going to happen is when you run QEMU, it's going to run your bootloader and you're going to get just hello world real quick. And that should be all you need. To make it easier to run our kernel in QEMU, we can set the runner configuration key for cargo. Huh. What does that do? Target.config OS, target OS equals none. Table applies to all targets whose target configuration files OS is set to none. This includes our JSON target, which we had up here. Our JSON target has various things. I forgot to turn my lighting on so I look pretty. The boot image runner command is specifically designed to be usable as a runner executable. Hello, darkness, my old friend. Anyway, so see the README of boot image for more details and possible config options. Okay. Let's go see what it says here. All right, so here's your cargo install boot image. To run your kernel in QEMU, yeah. Set configuration. Okay, so run command, drive format, okay. I didn't see the additional targets that he was mentioning. Oh, possible configuration options. Okay, so yeah, there's different options you can get here, including, when you run the command, you can tell it to always use x86-64, always use the drive switch, and what format you want the files to be run in. Additional arguments passed to the run command for non-test executables. So you can actually add different run args, like maybe, I don't know what kind of run args you would have for your boot image, but you may say limit it to 32 megs of RAM or, yeah. So there could be a number of different things here. Custom tests framework. Okay. But yeah, this would be great if you have enough knowledge to be able to create a custom kernel, like an Uber custom kernel for an application or for a system where you want to cut out pretty much any cruft that you're worried about. And in many cases, as we're going through this Rust kernel, I had aspirations at one time of, creating a custom kernel that didn't have any additional drivers in it, way back in the day for Linux. And then I got into the super customized Linux kernel UI, and it wasn't very friendly, and ended up breaking more things than it was worth because I wasn't a kernel dev. I didn't know what I was doing. So I would undo some things that were not necessarily documented correctly, and then nothing would work. And then I just gave up and, went back to playing Super Mario Brothers. It is what it is. It happens. So let's kill the terminal here. There we go. Yeah, GTK initialization failed because I don't have GTK installed, which, I could futz around with that a little bit more. The idea is it wants to bring up a window, because in later versions of WSL on Windows 10 and 11, you can now run X Windows on your desktop and, have run apps like QEMU or whatever from your WSL instance. Apt install GTK. Nope, I don't know what. GTK's probably got a lot to install. So, all right, what's next? We'll explore the VGA text buffer in more detail and write a safe interface for it. Okay, so far everything we've done was, untrusted, because the system or the kernel would not, or not the kernel, but the CPU and the memory storage doesn't trust us, or doesn't trust the code that we're injecting into it. So the next version of this is going to be using macros for print line, and also, making the VGA text buffer a bit more safe to use, which is great because he showed us the unsafe way to do it, and now the person's going to show us the safe way to do it. So one last thing, because I'm not making money off this, obviously. People subscribe to the stream here, but I'm standing on the shoulders of a giant who wrote this blog post. So please feel free to sponsor Phil on GitHub, or use Patreon if you can to give some love to Phil over here to creating a blog about OS development and Rust. I mean, come on now. So yeah, go and talk to Phil. Maybe we should have Phil on as an interview. That might be fun. Tried WSL2 last year. It was pretty garbage. I like it for text-based stuff. I haven't used it for OS level stuff. Or like I have my Ubuntu daily driver. I haven't ran any applications that needed a UI inside of it on the Stream PC. I like it for wget and curl and YouTube downloads and FFmpeg for converting and down converting video and audio stuff. But I don't use it for a ton of stuff on Windows. It is fairly full featured, but yeah. So, for $1 a month, you can support that, support Phil as it continues on. Writing a blog, OS, teaches basic steps, writing a small OS kernel, also creating and maintaining open source tools and libraries. So there you go. Help support an OS developer and an open source creator there. Might actually go in and pop $5 in myself just for shits and giggles. So I think it's well worth the effort. So, yeah. Cool. All right. Yeah, so I posted that up there. Okay, good. All right. We're going to VGA text mode. All righty. So, the VGA text mode is a simple way to print text to the screen. My worry is that if I go, hey, I'm doing this on my stream, and he's like, oh no, don't use that version, use this version because I fixed all the other things that are wrong in the new version. So go to the 2020 build of this, and I'm like, oh crap. But it's it is what it is. But like I said, support Phil because Phil's doing good work, and I'm following the directions, and they seem to be working. So that's big ups for me. So yeah. All right, so the VGA text mode is a simple way to print text to the screen. In this post, we'll create an interface that makes it usage safe and simple by encapsulating all unsafety in a separate module. Oh, interesting. Encapsulating all unsafety in a separate module. So it's almost like we're walling it off or creating some kind of bubble around the unsafe code to make it even more safer, even though it's still doing naughty shit. So this blog is openly developed in GitHub. If you have any problems, please open an issue there. Leave comments at the bottom. Complete source code for this post is found at post 03 branch. So here is the code for that. Let's go look at main.rs. Under source, main rs. Okay, so looks according to this, we're going to break out the VGA buffer.rs, which is the range bits. Let's go see if we look at this. Oh my. So we're going to start adding back in some, core FMT. Remember we talked about that one, yeah. Lazy static, spin, mutex, and volatile. Okay. Lazy static, a global writer instance that can be used for printing to the VGA buffer used by printbang and println-bang macros. All right, so we're dropping the no macros thing pretty damn quickly, and we're going to be right back into the thick of it here. So standard color palette in VGA text mode. Okay, so we're enumerating the different colors. We're going to be creating a foreground and a background color. All right, now color codes. So we're going to add quite a bit of code to this, so that's kind of good. Hello, moderator Angem. Thank you for following. Appreciate that. Glad you could come and rest around with us here. So, all right. So yeah, we're going to add a couple of 100 lines of code here. That's pretty sweet. Wouldn't it be cool if I could, this actually worked and I could, use it instead of the Linux kernel? Nah, that'll never happen. I don't have 28 million lines of code to be able to add to this. Okay, so, all right, so the mod VGA buffer, and then, obviously it's going to go look inside of the source directory for VGA buffer, right? So, no std, no main, use core panic info. All right, so we're, Huh, interesting. So this function is called unpanic. All right, yeah, we have all that. So yeah, everything's going to stay much the same except for the unsafe handling is going to go into its own Rust module in this case called VGA buffer. Okay, well that's good to know. We'll get a sneak peek of what's going to be happening by the time we get to the bottom of this doc. All the way down. Okay, so there's a good number of comments here. Let's see what this says. Excellent tutorial. Okay, good. As a Rust newbie, it's a great resource. All sorts of fun. Okay, when I call my implementation, I don't have to call unwrap. I need to call it from the macro. Okay, so cool. All right, I was just looking at the comments to see if anybody had any kind of issues. You can follow along as well. Here is the link to that. There you go. All right. The VGA text mode is a simple way to print text to the screen. In this post, we'll create an interface that makes its usage safe and simple by encapsulating all unsafety in a separate module. We also implement support for Rust formatting macros. This blog is openly developed on GitHub. Yes, complete source code is at post 3. It's open and free, so if you just want to copy paste, it's possible too. Here's a table of contents. Wow, so we got a lot. We got a lot to work on this time. All right. To print a character to the screen in VGA text mode, one has to write it to the text buffer of the VGA hardware. The VGA text buffer is a two-dimensional array. Okay. I don't quite understand why it would be... I don't understand if there'd be different dimensional arrays. So maybe that's something I didn't get with when I didn't get my CS degree. It just seems like there's an X and a Y, but you know, it is what it is. 80 rows or 25 rows and 80 columns. So that's 25 times 80. So 25 times 8 is 2,000 characters. 2,000 characters, really? No, surely not. Yeah, 2,000. Okay. I guess it's 2,000 like buffer, or the array has 2,000 in it, which is directly rendered to the screen. Each array entry describes a single screen, a character through the following format. So 0 through 7 is ASCII code points. 8 through 11 is foreground color. 12 to 14 is background color, and 15 is the blink. First byte represents the character should be printed in the ASCII encoding. So where in the hell is my... Okay, sorry about that. If y'all got sick, my apologies. I did too. I get motion sick. So, all right, so ASCII. Here's your ASCII characters. You can go look that up if you want them. The Wikipedias. There you go. All right. So, it isn't exactly ASCII, but a character set named code page 437 with some additional characters and slight modifications. For simplicity, we'll proceed to call it an ASCII character in this post. Code page 437. Oh, okay, yeah, we saw that earlier in the previous chapter. So this is the code page for it. It doesn't look like 25 by 80. I guess it's 25 by what? 1, 2, 3, 4, 5, 6, 7, 8, something around there. 8 or 9. I know they added these ones at the bottom on like the second and third from the bottom line, so they could make, you know, fancy boxes, and you know, back in old timey days, DOS shell was you know, something similar with a white background and what have you. So you can see all the characters in there. So you see all the lines and the, you know, the bolded or the backgrounds and stuff like that. So yeah, you see your up arrows and your down arrows and the shading and the different colors. So, all right. with some additional characters. The second byte defines how the character is displayed. The first 4 bits define the foreground color, the next 3 bits the background color, and the last bit whether the character should blink. The following colors are available. So you have 01 or 0x0, which is black, all the way to, they're in hexadecimal, right? So 16 colors. You get 16 colors total, which I believe was CGA graphics. CGA graphics back in the day? Yeah, I think so. So you have 0 through F. 1, 2, 3, 4, 5, 6, 7, 8, 9, or 0 through 9, and then A through F. Bit 4 is the bright bit, which turns on, for example, blue into light blue. Interesting. For the background color, this bit is repurposed as the blink bit. Alrighty. Text buffer is accessible via the memory mapped I/O to the address B8000. So as you see here with our B8000, that's where the VGA buffer is. This means that reads and writes to the address that don't access RAM but directly access the text buffer on the VGA hardware. So we're bypassing RAM in this case. It doesn't, the instruction says, hey, go write this directly. And that's, I don't want to say that's why it's unsafe, but, bypassing RAM, you can read and write through normal memory operations that address. Note this memory mapped hardware might not support all normal RAM operations. For example, the device could only support byte-wise reads and return junk when a U64 is read. Unfortunately, the text buffer supports normal reads writes, so we don't have to treat it in a special way. Okay. All right. Now we know how VGA buffer works, and I'm sure, let me go see VGA. I'm sure there's been all kinds of stuff written about it. I like Wikipedia. There's a lot of information here. Let me see, grab that. There we go. So you can read some more about the text buffer. You've got all your box drawings, see all the lines and everything. You have your blinking text. You have your cursor. You have all that. So here's the code points. Here's your foreground and background colors and your blink bit. So yeah, you've got your code. It's not 737. Didn't we just read it was 739 or something like that? Yeah. So 437. So I think they're wrong here. I think this is supposed to be 437, not 737. Oh, to write the Greek language. Weird. Okay. Oh well. I'm not a Wikipedia admin, so I'm not worried about the changing of the page. So, all right. Now that we know how it works, we can create a Rust module to handle the printing. So in source main RS, we're going to create mod VGA buffer, and as we saw from here, you just put it. We'll put it under line 6 underneath the core panic info. I think that's something that I've tried to understand in this is, are there certain places where you could put it, or could you put the mod VGA buffer anywhere? Seems to me that there's an order here, whether it be by design or by everyone just decided that's how they're going to do it. You could put mod VGA buffer on line 21 of your code. But that's not where it's supposed to go, because that's, I've been, somebody will be like, I've been writing Rust since you were in diapers and whatever. Maybe there's a logical progression to this where it's like, okay, I'm going to, read this line by line by line. And if mod VGA buffer is not where it's supposed to be, then it won't run correctly. I'm a little vague on that. Those are the kinds of questions my brain asks me at like 3 a.m. And I probably should, tell it to shut up, but it is what it is. All right, so in source main RS, I put my mod VGA buffer. For the content of this module, we'll create a new source VGA buffer.rs file. All of the code below goes into our new module unless otherwise specified. All right, so we'll go here and we will create a new file and we will call it VGA buffer.rs. All right, so vga-buffer.rs. So as you saw previously, we're going to add a ton more lines to this. So what we've got is, okay. RS. And we're going to allow dead code. We're going to derive, debug, clone, copy, partial equal, and EQ. And then I'm not going to type all this. I don't want to make people hate me. So I just want to type some of it. All right. So pub enum color. So we're going to set our color mappings, or denote which colors equal which. And as we saw, all the way from 0 to F, in this case, is black to white. And then we'll hit that, and then what I'll do is I'll just do the old CP here, copy paste, and then there we go. And then it says we use a C-like. Hello, wading through logs. I appreciate you coming and hanging out with me today as I stumble through Rust. You can check, I think, the stream chat up for the blog post and everything that we're going through. Hey, Wade. Oh, hey, Wade. How you doing? Glad to see you. I met Wade at our little mixer. We had about 90 people. We had a super mixer Wednesday night. At one of the local breweries here in San Diego. Lovely food truck, by the way. I didn't partake of any of the alcohol, but it was a nice time. I wish I'd have been able to stay longer, but the sun was setting and I was turning into a pumpkin. So I'm still learning how to be social. So we use a C-like enumerator here to explicitly specify the number for each color. Because of the REPRU8 attribute, each enumerated variant is stored as a unsigned 8-bit. I think it's unsigned 8-bit. Actually, 4 bits would be sufficient, but Rust doesn't have a U4 type. So yeah, unsigned 8-bit. I think it's repr is represent. Represent U8. Yeah, there we go. Sounds like a good time. Was it an official B-sides or just a meet and greet? So digital. It was it was like a super group of the WeSys folks, OWASP, ISC Squared, ISACA, the B-sides organizers, and I want to say there was one more group, but yeah, it's a quarterly get together with all of those super groups put together. Yeah. And then the week before that, the CISO series folks, which also had a get-together, which was different. CISOseries.com, I think, is the website. But they are also in San Diego, and they put out regular content for CISO level stuff, like Paul Asadorian does with the Security Weekly stuff. And they're planning on doing something on a monthly basis as well. A lot of stuff going on down here. I mean, we got a lot of defense contractors, a lot of auditors, a lot of the big 4 offices down here. So it's good to see a healthy group. And of course, B-sides San Diego is doing CFP right now. So put your paper in and come in down here. I think it was the end of 30 March, and they're looking for, there you go. Thank you, Wade. Come and join us down here in lovely San Diego at SDSU campus for, you said the day before Easter, and I was like, wow, that's awfully early for Easter this year. And he's like, I know. So, may not work for folks who, celebrate themselves some Easter, but, if you want to come and hang out, well, HushCon Seattle? What? Wait, is HushCon Seattle a freaking same day? That's not good. No, HushCon's in like December or something, yeah? December 8th and 9th, yeah, that's what I thought. Oh, is that old? I think that's old. So, yeah. So, yeah, December 8th and 9th in Seattle. So, yeah. Oh, yeah, HushCon has their CFP going on. You're right. My bad. Sorry, digital. Yeah. Another good conference as well, hushcon.com. You can sign up for their mailing list. If you know where to subscribe.php to it, you can find it and sign up for it. And then, so yeah, you can go and find all that and get involved. Just as long as you don't, take pictures or share it on social media or anything like that. So, all right. So because Rust doesn't have an unsigned 8-bit integer or 8-bit value, we're going to I think REPRs represent. It represents as an unsigned 8-bit value. And so normally the compiler would issue a warning for each unused variant by using the allow dead code attribute. We disable these warnings for the color enum. So allow dead code is going to allow you to, get around your warnings. So like if you had Python and it was used strict, it's going to tell you a lot of the different warnings. This allow dead code is more like a quiet function. Like, yeah, I know that that's going to be a problem. Just is what it is. I mean, you could fill it up with all the unsigned 8-bit values, but I don't know how much 8 bits is. It's a lot, actually. It's a whole lot. So you could add values all the way up in there if you wanted to, but it would be just a waste of space and time and lines. So that will squash those color enumeration warnings for you. By deriving copy, clone, debug partial EQ and EQ traits, we enable copy semantics for the type and make it printable and comparable. Copy semantics. Copy types. We've established that when ownership is transferred to another binding, you cannot use the original binding. However, there's a trait that changes this behavior, and it's called copy. We haven't discussed traits yet, but for now, think of them as an annotation to a particular type that adds extra behavior. For example, let v equals 1, let v2 equal v, and then print line v is v. In this case, v is I32, which implements the copy trait. That means just like a move, when we assign v to v2, a copy of the data is made. Unlike a move, we can still use v afterwards. Okay. All right. So that makes sense. Let me pop that into chat as well. Doink. There you go. All right. So let me close some browsery bits here. All right. So, to represent full color code that specifies foreground and background, we create a new type on top of the unsigned 8-bit. So in source VGA buffers, we have debug, clone, copy, partial EQ, represent transparent. What? Okay. Yes. Sorry, I just noticed my audio cable sticking out the back of my head. All right, so let me see where this fits in the system here. I'm gonna scroll back up to source and go into VGA buffers. So repro column position. Okay. So combination of foreground and background color. So those go after those at the very bottom underneath the values here. So we will put this here and we will shrink the terminal window. All right, there we go. All right, so we'll do derive, clone, copy, partial EQ, code, represent transparent, and then imply color code, IMPL. IMPL. Implementation on types. Okay, so it's not imply, it's implementation. So, all right. So implementation of the color code. So we're implementing a color code. So it's almost like a function for functions or something, since it's yeah. So I'm sure we'll call it at some point in the future. So then we'll do that. Doink. So FN new foreground color, background color is the color code. Color code background is unsigned 8. 4, and then pipe in foreground is U8. Interesting. Color code struct. Oh, we're creating a struct. Okay. Contains the full color byte containing foreground and background color. Like before, we derive copy and debug traits for it to ensure that the color code has the exact same data layout as the unsigned 8. We use represent transparent attribute. So can only be used on a struct or single variant enum that has a single non-zero sized field. There may be additional zero sized fields. Okay, so that's why we couldn't use transparent up here, because we have a potential zero field in black. If somebody tried black, it wouldn't work. That's how I'm reading that. So if somebody has any other different thoughts on that, but that's how I'm interpreting it. The reason you couldn't use, the same transparent code up here is because of that. Doink. By the way, this is all from the Rust language doc, so it's the Rust book, I think, is where all this, the Rustonomicon. Of course it is. Of course it is. Which can be, found at Rustlang, Rustnom. Oh, it says it's incomplete. All right, so there you go. All right, so delete that. All right. Text buffer. Now we can add structures to represent a screen character and the text buffer. So we have, I'm assuming this all goes down below as well. So derive, again, we add the same debug clone copy partial EQ, represent C, struct string green character, ASCII characters is an unsigned 8, color code is color code. So we're calling the struct that we created called color code in this case right here. And we're creating a buffer height and width of 25 and 80. And then representing transparent, which was down here, for the screen character, buffer width, and buffer height. All right. Says, since the field ordering in default structs is undefined in Rust, we need the represent C attribute. It guarantees the structs fields are laid out exactly like in a C struct, and thus guarantees the correct field ordering. Oh, okay. So you could mix them up? That doesn't make any sense. Why would Rust allow for something like that? It's really weird. Okay, let me go into part 3 and make sure that we're putting those in the right place. Okay, so we'll put it after the color code. Yeah, we put it after the foreground stuff. So all of that screen character bits will go here. All right, so. All right, so VGA buffer. So here's our represent C, screen character, ASCII U8, color code is color code, so it'll call the struct up here. Buffer height, 25 being the max size, 80 being the max size. So technically, if you don't have these, you could go above the buffer height and width, maybe. Const, I think, means constant. So that's not what I was looking for. There it is. Keywords, const. Constant. Okay, so yeah. So constant just says, the buffer height, that's as big as it's going to get. You can't, this is like a set in stone kind of thing, speed of light, gravity, etc. In this case, buffer height and width. All right. Since the field ordering defaults is undefined in Rust, we need the rep C. For the buffer struct, we use represent transparent again to ensure that it has the same memory layout as its single field. To actually write to the screen, we now create a writer type. So pub struct writer. So okay, we're creating a struct called writer column position usize, which is interesting. I wonder how it doesn't get confused about the usize on this. You would think it would call specific. Oh, column position usize. Huh. Interesting. The writer will always write to the last line and shift lines up when a line is full or on new line. So /n is new line. The column position field keeps track of the current position in the last row. Okay. All right. So it's its own usize, not anything related to the constant buffer width and height. The current foreground and background colors are specified by color code. Right there it is. Ding. And a reference to the VGA buffer is stored in buffer, right? Okay, so, all right. We need an explicit lifetime here. Really? Explicit lifetime. Yeah, one lifetime annotation. Okay, lifetime annotations don't change how long any of the references live. Rather, they describe the relationships of the lifetimes of multiple references to each other without affecting the lifetimes. Okay. So, lifetime annotations have a slightly unusual syntax. Names of lifetime parameters must start with an apostrophe and are usually all lowercase and very short, like generic types. Most people use the apostrophe A for the first lifetime annotation. We place lifetime parameter notations after the ampersand of a reference, using a space to separate the annotation from the reference's type. Wow. Okay. Somebody must have thought this was a good idea. I don't have any preference one way or another. It's just I'm not understanding the differences between like a reference and a variable and those things. So I don't want to look at that. It's got error messages in it. My code never has errors. So oh gods. Okay. All right. So we're gonna create this. We're gonna put it down here underneath. Writer will always write. Okay. Static lifetime specifies that the reference is valid for the whole program runtime. Okay, so static means, I see here. So this means when it's done, the buffer goes away, or the value in that static mutable buffer goes away. So it's not stored in memory, I would imagine. Printing. Now we can use the writer to modify the buffer's characters. First, we create a method to write a single ASCII byte. Okay. Implement writer. So it's a public function. Write byte. Okay. Wow, it's a lot of code. Okay, so let me double check and make sure we're putting everything in the right place. So here's impl writer. Okay, so it goes down below this here. There we go. All right. So just, I'm not cheating. I just don't want you to have to watch me type out stuff at 15 minutes to, get these things out. It would make my nether region start to sweat if something went wrong or I typed it in incorrectly. Or, I've had numerous attempts where cargo run didn't exactly run. And then I had to go back through and figure out, I made this screen with a lowercase char instead of a capital char and whatever. So, did Digital Warhead, you got blocked by our Autobot. Yeah, I'm gonna add that because I know that it's not well. I'll probably have to go back in and remove some permitted terms at some point in the future, but bite your ass key. Very very well done. I love the pun, so I'll allow it. Yeah, for now. I know in which it was delivered. No, it's all good. It's all good. And that's pretty funny though. Yeah, if the byte is a new line byte, new line, so that's the \n, or the writer does not print anything. Instead, it calls a new line method, which we'll implement later. Huh. So we have to implement our own new line method instead of using the \n. Oh man, today was leg day. I'm gonna feel that tomorrow. Anyway, so other bytes get printed to the screen in the second match case. So here's the first match case, and then the second. Where's the second match case? Second match case. Is there another match case up above that I... Nope. Buffer height 1, self column position. I don't know what he's talking about with the second match case, because there isn't a second match case that I can see. Yeah. Other bytes get printed to the screen in the second match case. Instead, it calls a new line. There's the new line, right? Buffer width. Self new line. Match byte, write byte. Okay. When printing a byte, the writer checks if the current line is full. In that case, a new line is called, used to wrap the line. And then it writes a new screen char to the buffer at the current position. Finally, the current column position is advanced. Whew. Good Lord. Okay, so yeah, I see that. Self-column position +1. Row, column, screen char, ASCII character, byte, color code. Right, and then let column, self-column position, buffer height -1. Right. Okay. To print whole strings, we can convert them to bytes and print them one by one. So we're going to implement a new writer. Implement a new writer. Okay, so we've got, it says to do. I don't know. That's never good. You never want to see code annotated with a to do. Oh yeah, by the way, I'll fix that later, right? Let me see. We have self position +1, func new line, mute self. Okay, so there's that. So to print whole, we can convert them to bytes and print them one by one. I think. Okay. Convert them to bytes for. Okay, so write byte. UTF-8 byte. Okay. I'm just trying to make sure I don't clobber anything. I don't see the func new line, so maybe he gets rid of that in his... Yeah, I'm guessing maybe he gets rid of that in his next system here. So, all right. So we'll implement another writer below this one. I don't see the mute self in chapter 3. I'm thinking maybe I should just comment it out. I don't see a to do in here. TO. DO. Okay, so yeah, there's not there. I'm gonna, just for my own sanity, because if I ever do a cargo run or something on this, whoops. If I ever do a cargo run on this and I get an error message, I'll be trying to figure out why this may or may not work. So, all right. The VGA text buffer supports only ASCII and additional types of code, page 37, which, as we saw in one of the Wikipedia pages, I think they made a mistake and it's not 737, it's 437. Rest strings are UTF-8 by default, so they might contain bytes that are not supported by the VGA text buffer. We use a match to differentiate printable ASCII bytes, a new line, or anything in between a space character and a tilde. That's a tilde, which is the character above your tab key, as well as the accent mark, and unprintable bytes. For unprintable bytes, we use a white square, which has the hex code 0FE on VGA hardware. Oh, okay. All right, so to write some characters on the screen, you can create a temporary function. Okay. So let me see where this goes. Temporary function. Okay, I don't think that actually goes in to the final product here. So VGA buffer RS print something, let mute writer equals writer, column position 0, right? Color code yellow and black. Buffer unsafe. We're going to, at mute. We're going to inject itself into the VGA buffer as mute buffer. We're going to write hello world. Looks like we're going to try to, the B is bold, potentially. It creates a new writer that points to the VGA buffer at B8000. The syntax for this might seem a bit strange. First, we cast the integer B8000 as a mutable raw pointer, right? Which, is the unsafe bits. Then we convert it to a mutable reference by dereferencing it through the asterisk. So there we go. We're dereferencing it. So we're doing exactly everything we're not supposed to do. One of the 5 not. All right, digital word. See you later, man. We're dereferencing it and doing everything we're not supposed to do, and one of the 5 things we're not supposed to do immediately into this, and then we're immediately borrowing it again through the mute at mutable. This conversion requires an unsafe block since the compiler can't guarantee that the raw pointer is valid. Right. Okay, I see. So that's what the output's going to look like when we compile this thing and start over. Then it writes the B H value to it. The B is a little byte literal. Okay, byte literal. All right. Byte literal. There you go. There's that. Byte escape, so /x, and then other escapes are N, R, T is tab, R is carriage return. Yeah, and then you can escape the escape, so you can get a backslash. I'm unaware of what these are. Interesting. I mean, you're escaping single and double quotes on that one. I don't know why you would escape a 0 yet. I'm sure I'll figure that out at some point. Anyway, you can go and read through that. So, which creates the ASCII character by writing the strings LO and world with 2, circles or two dots over the top. We write our write underscore string method and the handling of unprintable characters. See the output, we need to call the print something function from our start function. So we're going to go back to main RS under no mangle. So main RS, no mangle, pub turn, extern, C func start, bang, okay, VGA buffer print something. Okay, so we'll change, Okay, so we're going to remove all of this. Print something. Okay, and then loop. So now when we run our project now, the hello, okay, so it should be printed in the lower left corner of the screen in yellow. Notice that the O is printed as 2 square characters. That's because O is represented by 2 bytes in UTF-8, which both don't fall into the printable ASCII range. In fact, this is a fundamental property of UTF-8. Individual bytes of a multi-byte value are never valid ASCII. Okay. Holy crap. So we're at 1 hour and 32 minutes, and I'm a little hungry because I did leg day today. Looks like we're still a good ways off from finishing this. So I'm going to stop because one of the things I want to do is I want to actually get QEMU set up so that when I do run these things in QEMU, it works, or VirtualBox, whatever the bin file is. I should be able to run the bin file in VirtualBox, and it should pop up something that says "Hello World" or "Hello, a moose once bit my sister," or whatever the hell this is down here at the bottom on this screen here. So, yeah, we'll make that happen. So, I'd like to thank everybody for coming. I'd like to thank Wade and Digital Warhead and Freedom DAO for sitting with me here as I work through some of these items. If you have any feedback for me, please let me know as I continue on through this. I would like to share the love here and see who we've got up and running. Strager's on. Anybody have anything else they want to talk? Student. Shroud. Pone College. Let's go follow Pone College. I don't know Pone College, so it's going to be a mixed bag. So, but anyway, I'll be sticking around here for a few minutes watching Pone College, probably Hack the Box or something like that, which is always a good time to learn that stuff. But I hope everyone has a good good weekend, and you take care of yourselves. So I will be back on Tuesday, hopefully with an interview that I'm still getting ironed out, but I think it'll happen. And yeah, but otherwise, yeah, let's go see what Pone College is doing. So there it is. Okay, we're gonna raid them now in 3, 2, 1. All right, everyone, have a good day. Later, bye.